Hello, I wanted to show you a quick video of how to set up the equipment for our time-dependent data / DAQ lab. We had a number of videos leading up to this showing tips and tricks and just a general intro to LabVIEW, and then how to specifically set up the VI for this lab. I've created a very simplified version of the VI here. Essentially, we just have our DAQ assistant with controls for the rate and the number of samples, and then our waveform graph. And I haven't set it up for the range or the rate or the number of samples or any of that to be what you need to do for lab. You need to look through the lab handout and make sure that you enter all the right values, and you should know how to do that from the previous video. I did hook up a USB 6001 through the DAQ assistant and ran the first channel AI0. That's the data I'm collecting. So here we're seeing that USB 6001. It's plugged into the laptop via USB. It's running behind it. But here on channel 0, or AI0, the first channel, you'll see that we're plugging in to the second and the third terminals there. If you look closely, you'll see there's a plus and a minus. The lighting might not be the best for that. Let's lift this up. There we go. That's a lot better. So you'll see AI0, and you see the plus and the minus. It's the second and third terminals in that block. We have our positive and our negative going in there. So there's a little bit of flexibility here in how you want to do this. I would recommend doing the most simplified thing. I have maybe a few extra components just to extend the length of it. But I have these banana plug cables. They're cut off on one end. So the end where it's cut off, that's what I'm connecting there to the USB. We just use these small little screwdrivers. There should be one of these USB 6001 DAQs and a small screwdriver at your station, possibly in the big yellowish orange Fluke box. But don't get banana plug cables and cut the banana plugs off of one end. We should have plenty of them that have the ends cut off. If not, let a GTA or instructor know, and we'll get you some more. But here we just have a few connections to go from these banana plug cables to a coax cable, where we have both cables on the same axis, and here it's coming out of our function generator. So there's some pretty new, nice function generators. You can see, I just turned it on here by default. These are the settings. And you can see there's frequency, there's amplitude, and then there's a DC offset. Those are the three things that we're going to need to set. And you need to look through the lab handout and make sure you set these to appropriate values based on what you're supposed to do in the lab. But just to show you how to adjust them, say we want to adjust frequency. Come over here, we press the frequency, and then we can type in what we want. So let's say we're going to do 100 hertz. So 100, and over here we have these buttons for different values. It could be megahertz, kilohertz, or hertz, millihertz. We want to be hertz. So you see that changed from 10 kilohertz to 100 hertz. Now the amplitude, we press that to switch the amplitude, and let's make it 3 volts. So 3, and then the V there for volts. Note, here we see the frequency. Over on the right, we see the amplitude. But now it's 3 volts, and note the peak to the PP. So volts PP. It's volts peak to peak. From the crest to the trough of the wave, we should see 3 volts. And right now the DC offset is 0, so it's going to be centered on 0. Let's adjust that and shift it up 1 volt. So there, that's everything we want. Now, it's all set except for we need to turn on the output. The function generator is on, but we need to turn that on to get anything out of it. So now that signal should be flowing down to our DAQ, and here let's run it once to see And there, that's exactly what we want to get. So we have, see, it's centered on 1, so we have a 1 volt DC offset, and it goes from negative 0.5 up to 2.5. So there's 3 volts peak to peak. Read through the lab handout carefully to see what values you should be putting in, and you need to run this once where you're sampling, following all of the rules like Nyquist theorem, and then you need to do it again where you're undersampling. And I would recommend, just to make it a little more intuitive, to sample something that is close to sampling it correctly, but satisfying that undersampling of the second part. That's it.